Our next speaker is Eleni Angelou. She's a PhD student in the philosophy program at the SUNY Graduate Center. She's currently a visiting researcher at the Center for Science, Technology, Medicine, and Society at UC Berkeley. Her research focuses on scientific cognition in both human and artificial agents. Eleni is also interested in questions related to technological progress, innovation, and the meta-science of AI safety. And tonight she'll be telling us about an overview of problems in the study of language model behavior. Eleni, you're welcome to share your screen and begin.
Thank you so much. All right. Thank you again, Kai, and welcome to my talk. I will be discussing 5 problems in the study of language model behavior. And towards the end of the talk, I will try to sketch out a research path of, let's say, behavioral psychology for language models or machine psychology. To briefly motivate this paper a little bit, the main background thought is that language model behavior can, to some degree, give us some indications for how language model cognition works. It can give us some tools for evaluating novel behaviors, and it can especially help us interpret some warning signs, for example, when models start becoming situationally aware. And obviously, all these would be very useful tools for AI safety, both for technical alignment, but also for policy making and AI strategy and governance. So, sorry, for some reason, I cannot change my page right here. I start with a problem of more of a philosophical nature, because I have noticed this coming up very often within different contexts of discussing AI risk, but also AI and in particular language model cognition. And that's the question of where is the meaning? Okay, we see these models, they output text, but is there semantic content there? Do they carry semantic content there? And I think the answer here that at least I can provide is that, of course, yes, they can provide semantic content, but there's also another question about, okay, what are their psychological states? So that seems to be a division here in philosophy of language and philosophy of mind, of something can have meaning if there is semantic content, but also if the agent making these utterances has a psychological state. And I think I can very positively agree that they have semantic content, but there's no clarity on psychological states. But I want to argue that semantic content is enough for what we're discussing in terms of whether these models could be dangerous or not. And recently, there's been more work that supports that language models can have meaning, and they probably corrupt the world in a way similar to that of humans, and maybe a sign that they become more and more situational aware, that they are able to predict what they know. So now, 2 arguments for why language models have semantic content. In one theoretical framework of how human language works, we may think that this next word prediction or next token prediction for language models is a very similar mechanism, even though humans and LLMs have very different access to data. And the second argument is that human language users can have meaning without reference to real-world objects. Just in brackets, we often hear an argument along the lines of, well, LLMs don't really refer to physical world or external world objects, so maybe they don't have meaning at all. And humans also seem to often not refer to real world objects, so why would that be a problem for AIs? So why do I mention these arguments? Why are we interested in that? Like I said earlier, there seemed to be a problem of reference often coming up in AI alignment discussions and AI risk discussions, that if we assume that all the AI can do is output words, that makes it not really dangerous. And as I note here, that's often a reaction, a first reaction to AI risk. It's just words. It's just next token prediction. But again, humans very plausibly function using similar mechanisms of next token, next word prediction. And secondly, and very importantly, advanced AI systems may be able to output text that would be dangerous by itself. Just some examples of what that text could look like. And of course, language is associated with the development of other cognitive capacities that could be coexisting there and leading to more dangerous, more powerful systems. And a final note on this, that the outputs may be seeming aligned with what the human developer wants to have the model output, but the model might still not be thinking what it's saying, thinking in quotes, because there's also a question about attributing mental states to models, but again, hinting a little bit to deception and the capability for deceptive behavior here. The other problem that I was interested in was robustness. A simple question: can the model execute a task reliably? What does reliably mean here? Regardless of small, subtle input variations for the same task. This is, of course, an important capability, could turn models into important economic actors, but it's obviously a safety feature that helps us measure how well a model generalizes and also helps predict future behaviors. Obviously, the more robust, the more reliable the model, the more potentially controllable, because we will be able to model its behavior more accurately. And here, a very quick experiment, prompt engineering experiment with the base GPT-3 model ADA in zero-shot, one-shot, and few-shot prompting, just to show that ADA does not reliably get the correct result. It requires few-shot prompting to succeed, and I'm just showing the screenshots from the playground where ADA gets the correct result in the few-shot prompting setup. Similarly, what affects robustness is a problem of changing the temperatures, right? So changing some features of the system, essentially. And again, here, a comparison between different temperatures. So zero-shot prompting for ADA, I don't change the kind of prompting. Here, I only change the temperature. And we see that the model can output the correct result for temperature 0.1 and for temperature 1. Why doesn't it output it for 0.7? Should this observation count against the model's robustness? And the question is no. In fact, that's something that one would expect because of how sampling works. And it is what one would expect as well if the model understood sort of what it's doing in picking randomly from its distribution. Now, with fine-tuned models, in particular fine-tuned with RLHF, of course, by default and by definition, what RLHF is meant to do, it makes the models more capable and makes them, especially bigger models like GPT-4, it gives the prompt engineer and the user this experience of as natural as possible, as if you were talking to a human. from some approaches, prompt engineering might become less and less important as models become more capable, although that is something kind of open to discussion. I'm just offering one take here, that models becoming better at following instructions should be expected to perform better at a certain task. And here I just compared the base model Curie and the instruct version of Curie. And of course, the first needed few shots, just like with Ada before, while Curie instruct beta just got it right from the first try. Two questions about fine-tuning and fine-tuned models, again, for RLHF versions. What does fine-tuning do exactly? Is it some kind of stripping off of some capabilities just to make it focused and much more capable in one particular domain? And then, or is it some kind of other alternative for the model's cognition? And of course, particular questions about how different kinds of fine-tuning impact the model. For example, we have observed that RLHF makes language models have stronger political views. So it seems that different kinds of fine-tuning can have different influence on how the model behaves. And that's probably a feature and not a bug. It's something generally desired for the models. Another problem that I'm interested in discussing here is the problem of situationism. I take this situationist hypothesis from social psychology. What it says, it's essentially that you put a model or a human into a different environment, slightly different content, and that makes a big difference in the model's outputs. Again, it's important here that it's for the same task, while we sadly change the prompt. Of course, it's not for different tasks. And the claim here, or the observation here, following the situation hypothesis, is that base models are sensitive, of course, to the tokens they condition on. That's just how the model works. And they will not output the correct result unless it's part of their continuation trajectory. And like we said, what fine-tuning does is that it makes the models feel as natural as speaking with a human as much as possible. But again, the context seems to make a big difference. Certain phrases help the model assign a higher probability to the correct answer. Why is this a problem now? So first, it might be an indication that models don't really care about truth. They're not going to be outputting truthful results, but rather careful prompt engineering. And as prompt engineering becomes more and more sophisticated, it might be able to push the model towards different directions, regardless, again, of truthfulness, but more of from the user's perspective. And secondly, the model could exhibit unexpected behaviors, right? So like I said earlier, some phrases seem to improve or change the model's performance significantly. Recently, this prompt, take a deep breath and work on this problem step by step, but we also knew before this paper that reason step by step is something that helps the model improve its reasoning significantly and therefore have much better performance. So that's something to keep in mind, that context really impacts the accuracy of the model's results. Now, the situations hypothesis seems to be a pretty good way to frame this, even though I'm not entirely certain what predictions we can make with it. It just seems more like a framework for treating the models as dynamic systems, and helps us keep in mind that they could surprise us. They're not static. They could surprise us either positively or negatively. And I think that's also something that helps argue in favor of why AI could be a risk, or why we could be observing unexpected behaviors in maybe in current systems or future systems as well. And of course, the difficulty of AI alignment. And another observation is that the situations hypothesis seems to be pretty widely understood by machine learning engineers and developers who place language models in different contexts and have them interact with other software and do scaffolding work and try to elicit new behaviors from the models, such as future planning, goal-directedness, or even some sense of autonomy, such as baby AGI. The other problem here that has been pretty difficult to interpret and meta-analyze, I guess, the results is sycophantic behaviors. What is sycophancy? It's a tendency of the model to output content that either repeats back whatever the user's answer is, or seems to agree with the user's preferred answer. And so it does not output consistent or objectively correct outputs. And like I said, I'm going to discuss 3 different experimental results, 2 in favor of observing that give evidence of sycophantic behavior in language models, and 1 that finds that there's no sycophantic behavior. So the first is a paper by some researchers from Anthropic, and Anthropic models. They find evidence for sycophancy, especially with scaling, both bigger models and more difficult complex tasks. And the important warning in that paper is that as we go into more difficult tasks, it might be increasingly more difficult for human developers and supervisors to evaluate the outputs. So obviously, sycophantic behaviors become even more problematic there. And a more recent paper by Google DeepMind finds more evidence, again, sycophantic behaviors with some of Google's models. And here they propose a solution with synthetic data intervention, where they add some synthetic data to the model and do some extra fine-tuning, which helps the model be significantly less sycophantic. Recently, though, an alignment forum post by Nostalgia Braced finds that base models do not become sycophantic at any size. We're referring to OpenAI models here. While 2 of the OpenAI models are sycophantic, TextAvinci 002 and 003. However, scaling does not seem to influence sycophancy. And now it's a matter of meta-analysis to figure out what's happening, where the truth lies in this experimental results. Now, another difficult problem in language model behavior evaluations: how do we rule out what a model cannot do? With tasks that we want to find what they can do, it seems pretty straightforward. We try to set up an experiment to test for a specific task, but how can you rule out what the model is not able to do at all? And if the situation hypothesis says something meaningful about the nature of language models, it's not unlikely that even available models could exhibit undesired behaviors, such as power seeking, or not be able to be shut down by human developers. Some ideas for how to go about this is look at the logits, which are the model's true answers, then to do some more experiments like researchers are already doing, for example, some work by the ArcEvals team. How would language models behave in real world scenarios, and try to see how they would interact with online platforms and more complicated real world tasks. And of course, making prompt engineering more interesting and more complicated with meta prompting and using AIs to prompt with humans, so combining human efforts and automation. Now, very quickly, because we're running out of time, I will try to give a few takes about this emerging field that is machine psychology, or language model behavioral psychology, one might call it. So the first path to impact from machine psychology is to complete this picture of language model cognition. What's a good way to do that? More interaction with language models seems to be the best way to generate intuitions about how the models think. Try to find similarities and analogies between human and AI cognition. Try to leverage whatever methodological tools we may have from cognitive psychology, but at the same time, not to fall into any anthropomorphic confusions, and trying to remain close to the mechanistic level of how language models work. So here there is already plenty of work in cognitive psychology that could inform tests with LLMs, either vignette-based investigations, or task-based investigations, to try to learn more about how language models think. And it's reasonable to expect that as machine psychology matures, we will have more and more tools that will help with AI alignment, especially if we're able to show how models obtain capabilities that are important in AI risks, such as situation awareness or goal-directedness. This will be a very important step in making progress in the alignment problem. All right. Just a few conclusions before the Q&A. Resolving the problems that I described will be very helpful in building a more complete theory of language model cognition that could serve as a guide for more explainable, predictable, and therefore controllable models. Understanding model behavior is a good first step in making sense of minds that may be very different from ours, but they seem to be exhibiting similar cognitive capabilities, so there's something to explore there. And finally, for the field of machine psychology, there's clearly a need for developing scientific tools that will help assess language model behavior, make this research more systematic, and it could inform both technical AI alignment, AI governance, and strategy in general. Thank you so much.
All right, thank you. I think I speak for everyone wanting a virtual round of applause as well. Thank you so much for the fascinating talk. Let's give it 1 or 2 minutes for questions. We still have some time left. All right. If none are coming in, then I'll start with kind of my question, which is, what do you think are kind of like the key takeaways from building this kind of psychological profile of how different large language models work? Do you view it more as something, so like an individual user could use it for prompt engineering, or do you think there would be some applicability to kind of crafting regulations and so forth as well?
Sorry, crafting
Regulations or something like that to large language models, or just in general, what do you think are the applications?
Yeah, I think there's a one side of this debate of trying to how much can cognitive psychology help us have this theory of language model cognition, so entirely at the theoretical level, how do these minds work? They seem to have this very powerful capabilities. They seem to be different to us in many ways. The mechanistic level is pretty different from ours. We're not that we fully understand how human minds work, of course, but so there seems to be this theoretical discussion of like solve language model cognition, and the application of that, of course, is that the more you solve, the more you learn, the more you model these minds, and the more predictable they become. And like I said, I think this could serve as a guide for how do you use this, some kind of manual, right? If you understand this mind there. So in that sense, there's this theoretical part. At the same time, I think the field of AI safety very much needs more experimental and systematic work. And so I think that if you have experiments, empirical work that utilizes tools from already established scientific fields, it might be possible to demonstrate these results more clearly. And so in that sense, having this experiments could also function as here's something to show to policymakers, to have more convincing governance arguments. So that's the more practical application. Here, concrete examples of how these models could, for example, start exhibiting, powerful capabilities or situational awareness, and here's how that could be dangerous.
Great, thank you. We now have 2 questions in the chat. I'll take the first one first. When I look at social media, it seems to me most people are sarcastic parrots. Wouldn't that prove that large language models can be just as impactful on society/social outrage? From Patrick Leo.
Sure. Yeah. I mean, if we're trying to like find similarities between, I guess, the social activity of humans and the social activity of LLMs, although I haven't really been interested in the role of LLMs in that context that much. Yeah, I think there could, yeah, I don't know if it proves that exactly, because it seems that LLMs are used by humans, so I think there's some kind of mediation there. But yeah, I don't necessarily see why not. Great,
thanks. We have one more question. I think we should try to get to it because I think it's very interesting, from Martin Soto. He asks about situationism. It seems like manipulating large language models is generally still easier than manipulating humans. Do you think this is only a quantitative or also a qualitative difference? Should we expect exploits to continue being findable? Is this a reason for hope?
Yeah, that's a great question. Thank you, Martin. Yeah, I'm not really sure. If you go back to this situations hypothesis, right? It proves too much if you say, in general, you put an agent, you put a human into different contexts and you elicit different behaviors, and you're saying that with prompt engineering is very successful for LLMs, and it's not as successful for manipulated humans. And I think maybe that's a question there about agentic behavior, and that agency comes in degrees. So of course you can, even a very robust agent can be put in a context and where you are going to be eliciting behaviors that very much contradict with that agent. So this seems to be a question about how agentic these LLMs are becoming, so that the context, the situation does not impact them as much. But yeah, I think there is this is a question about varying agency, right, and varying robustness. So maybe, so if we agree that it's just about agency and agentic behavior, then there's no qualitative difference, and it's just quantitative and a matter of degree of agenticness. But yeah, I'm not sure if that's the only difference. So that's a great question to think more about. Yeah, thank you.
Great. Fantastic. Thank you so much.